Okay, so we are technically done with the paper 2D example. You guys have seen how to set up a character and get some animations going. It's enough to make you dangerous. Now this video I'm doing strictly for the fun of it. I was playing around with this setup and I wanted to make a somewhat intelligent lift system to kind of move the character around in the level, and I thought, you know, why not go ahead and just make it into a training video. So let's go ahead and just get rolling. I'm making this up for the most part, so if it gets a little bit scattered, I apologize in advance. Let's start off by making a new blueprint. So I'll go into my blueprints folder, right click, and click on blueprint. We'll base this off of actor, and I'm going to call this 2D lift. But I'll give you a heads up. The system that I'm using would apply just as well to 3D if you wanted to make this a 3D lift. Okay, so inside of this, we'll go ahead and open up, oh, I still got my character open. Let's save that and close that. We don't need that anymore. Here inside the 2D lift blueprint, let's jump right into components, and in sprites, I'm gonna find my platform sprite, and I'll drag that in, and we'll call this the lift sprite. Actually, I should probably also have a scene component. Now, the reason you have a scene component is if you want to move any of the components, like in this case, really all I want to see is just this sprite component. But I want this sprite component to move individually of the actor itself, so I would have a scene component to kind of set things off. So we'll add a scene, and I'll call this root, and I'm going to drag it up on top of lift sprite, and that'll become the new root, and lift sprite will be parented to it. That's exactly what I want. Also, I'm going to make sure that this sprite is set to probably block all would be better than block all dynamic, but even block all dynamic should be fine for now. We'll just kind of keep an eye on that later if we ever need to change it. Okay, so that is the basis for our lift. If we wanted to, we could go ahead and jump over to blueprints, and we could drag a copy of it into the scene, which is great. Now, there's some things that I would like to be able to control straight from the details panel when I'm working with this blueprint. So those are going to be public variables, and I want to go ahead and just create those now. So let's create a new variable, and this will be end location. This is going to be the point in space where we want the lift to move to. So that is going to be a vector. So let me make this nice and big so everybody can see it. We'll take the variable type and set this over to a vector, like so. We'll make it public, and just to be on the nice side, we'll give this a tooltip. We'll say where the lift is going. That way the little eyeball turns green. That's the only one of those I'm going to type a tooltip for. I just want to point out that once you add a tooltip, that does turn green, which is generally what you want. Also, let's set a category for these. We'll call this lift controls, just so that everything is nice and organized. Okay, now the next thing I want to be able to control is how long it takes the lift to go between its two locations. So we're going to call this travel time in seconds. And we'll go ahead and set the category to lift controls, and we will make this public as well. Now, it doesn't need to be a vector. In fact, this is just going to be a float, because it's just a number that we're going to set manually. Now, let's see, some other things. I would like to be able to control how long the lift stays at either location, either at its beginning or its end. So let's make a new variable, and we will call this the stop delay. So it's how long, or how much of a delay there will be while the elevator is stopped, and we will set the category to lift controls, and again, we'll make this public. And let's see, what other things would I like to be able to control? I would like to be able to set the lift's color. So let's add a new variable. We'll call it lift color, and we will take the variable type, and I will set this over to a linear color. Again, we'll set its category, and we will make it public. And the last thing I want to be able to do is test the end position. And I shouldn't be searching. I should just be adding a new variable. So I'll add a new variable. I'll call test end position, or end location. Let's keep our naming consistent. And press enter, and let's go ahead and set the variable type over to Boolean. And again, we're going to set the category, and we're going to make this public. Now, the reason we have this is so that as we are working, and we want to know exactly where the lift is going to end up if we need pixel perfect control over that end point, we'll be able to have that. Now something else too, on the end location, we're going to do a couple of things real quick. Let's make sure we compile. And after we compile, we're going to make sure we show the 3D widget for this. And we're going to set the default value to 0, 0, 100. So the end location will be 100 units up above the original location of the lift. Now if we compile this and we get this out of the way, you can see our lift now has this little widget that says end location, and we can move that around. We can put that really anywhere we want this to be. Okay, so now we can start creating some of the logic for this, this lift, and I'm going to start off in the construction script to get some of the initial behavior out of the way. So the first thing I want to do is set the relative location based on how we test the end location. So let's do that. Let's start off by grabbing our lift, so we'll bring in the lift sprite, and we are going to set its relative location. And all this is going to be for is for allowing us to do that test end location trick. So there's a couple of different ways we can do this. The way I think I want to do it is with a select vector. So we'll do a select vector. Now this is just going to take in two different vectors, and you choose whether or not you're going to be picking A. So let's take test end location, and we'll plug that into our pick A. So if we're testing the end location, then we want to set our relative location to end location. That's perfect. And if we are not testing, we're just going to leave this set to 0. So we'll plug this in like so, and let's give this a quick test. You can just see that graph real quick. So compile and save, and we'll move this out of the way. And even right here, we don't even need to really hit play or anything. We can just check test end location, and you see we jump right up to that end location. So this is useful. Like if I had another platform floating up here, for instance, and I want to make sure that my lift is going to take me right up to that location and be flush with it, then I can select my blueprint. We can turn on test end location, and I can just move this so that it's nice and flush with that edge, and then boom, I've got my two different locations. So that's nice. Okay, so now that we've got that set up, the other thing I'd like to establish over in the construction script is setting the lift's color, which should be pretty easy. We're just going to take our lift sprite and we'll drag another wire off of it, and we will make a call to set sprite color. And as you may recall, the default material is going to use vector color, which ties directly into sprite color. So we can plug this in, and we will set our new color to the lift color. Now, it'd probably be a good idea to make sure that our default value for this is just going to be white. So we'll set that. We'll also make sure that alpha is set all the way up. And we'll click OK, compile and save. And we can just get this out of the way for now. So there's our lift, and there's lift color. So now we can change that, and you see the lift color updates as we make those changes, which is perfect. That's exactly what we want. Okay, so that's the construction script. That was pretty easy, I think. So now we get to do the event graph. The event graph is going to be a little more involved. There's a few more things we want to do. So we're going to start fairly simply with just a timeline to help us drive the movement. So let's just click on Add Timeline, and I will call this the lift timeline, because it's nice to have that with a good name attached to it. We'll double click and open this up, and I'm going to add a new float curve, which I will call my driver. Now this curve is going to be super simple. I'm just going to shift click 2 points down. Point number 1 is going to have a time value of 0 and a value, or time of 0 and a value of 0. And then we'll take point number 2, and that's going to have a time of 1 and a value of 1. Make sure you check autoplay, and make sure you also check use last keyframe, but do not check loop. We don't need loop. Okay, so now with that done, we can actually close out of here. Our timeline is all established. Now back over here in the event graph, we just need to set up the behavior. Now, when this timeline updates, we are going to need to move our lift, and we're going to do that again by setting the relative location. Well, not actor relative locations. Let's get our lift out so we can talk directly to it. So we'll drag out lift sprite. We'll get that, and now we'll set relative location. And there we go. So we'll do this whenever the timeline is updating. But the question is, what are we going to be setting the location to? And to set this, we're going to do a lerp between two vectors, or a linear interpolate. So let's just type lerp, and you should see lerp vector. And we'll go ahead and plug that right into new location. And we just need to give this two different positions. So we will take end location, and that will become point B. And the way a lerp works is that with an alpha value of 0, you are using the value in A. As alpha blends up to 1, you blend over to whatever value is in B. So we're going to go from 0 to our end location, and the alpha will be driven by our driver. If you wanted to, you could actually go into your timeline, and we could probably rename this to lerp alpha, and it might be a little easier to read down the road. So I'll go ahead and do that. So now you can at least see what that's being used for. OK, so that is handling the animation pretty well. We could do, just for vanity's sake, we could do a reroute node here and move that down just so that things don't overlap our nodes, make things a little easier to read. OK, so now that technically gets things started. Our lift will now just play up to the end and will stop. In fact, we could go ahead and give that a quick test. We can get this out of the way and simulate, and yep, you see the lift moves, but that's all it's going to do. It's never going to go back. So the next thing we're going to do is set some behaviors that allow us to oscillate back and forth. So to make this happen, we're going to do some custom events. So let's right-click, and we'll do a custom event. We don't really have to do custom events for this. We could wrap some wires back around, but this is going to make things a little easier to read, I think, in the long run. So this first custom event we're going to call lift forward. You could call it lift up, but I don't want to guarantee that my lift is always going up and down. It could go side to side, forwards and backwards, and front ways and sideways, and any other way you can think of. Let's go ahead and add one more custom event. And this will be lift backward. Or just lift back, however you want to call that is fine. And we're going to plug this into reverse from end. So notice I'm using play from start and reverse from end for these. Now, how are we going to call these custom events to make this happen? This is where things start to get interesting. So we are going to first execute something as soon as the timeline has finished playing. And finish will be called whenever you play from start and reach the end, or whenever you reverse from end and reach the beginning. In both cases, finished will actually fire. So we're going to drag a wire off here. And remember, we had a stop delay for how long we wanted the lift to stay in place after it moved. So we'll drag a wire off here, and we will fire off a delay. And we'll just take our stop delay and plug that right into that delay, like so. OK, so once that delay has run out, and we should also probably give that a default value. So let's go over to stop delay, and we'll set that to 2 seconds, and compile and save. Now, after that delay is complete, we want to perform a switch, essentially. We want to say, let's figure out what direction the lift just traveled, and then we will travel in the opposite direction. So we already have a direction. This comes along with a timeline for free. I'm going to drag a wire off this and search for switch. And this allows us to switch on that timeline direction. And you see, it's already got an output for forward and backward. And that's just there by default. We don't have to do anything special for that access. Now, from forward, if we were going forward, then we want to run the lift backward. If we were going backward, we want to play the lift forward. So I'm going to drag a wire off forward, and we'll just type in lift back, and there's lift backward. And then from backward, we'll drag a wire off, and of course, lift forward. OK, so now that is making calls to both of our lift custom events. We could probably test this at this point. So let's drag this off the screen, and we'll simulate. Actually, let me use my screen space kind of cleverly so that we can actually watch the graph execute at the same time. All right, and there's the delay, and then 1, 2, awesome. And will it keep going? Yep, so there you go. It's going back and forth. You could arguably say that we are done at this point. But there's actually a problem that I'd like to solve since we're here and since all that went so nice and smoothly, almost like I know what I'm doing. If we play the game now, we have a lift, and when it gets down here, I can jump on it. Oh, or can I? Actually, I just need to make sure that it is at 0 in y, and it wasn't. It's at negative 135. It got dropped to the background. So we'll set that to 0, and we'll play again, and we'll wait for the lift to come back down. And there we go. So now we can stand on it, and it runs us up to the top. And that's perfect. That's exactly what we wanted. But the problem, actually, is if we get under it when it's coming down, we can get some funny little physics errors that are less than ideal. So you see we kind of get trapped inside of it. Bump. So that's not so good. So what I want to do is have the lift reverse direction if it runs into the character. So this is a pretty easy thing to set up. Let's just take our lift and jump right back into its graph. Now, what we're going to do is add a component to the underside of the lift. We're going to have something that can potentially overlap, kind of like a safety zone. And so let's add a box component. And we will parent this to the lift sprite, so it's going to follow along. And I'm going to name this Safety Collider. Now, we need to size this up a little bit, so I'll center it up kind of close to the bottom. Make it fairly wide. I can thin it down a little bit. So something about like so, I think. That should be just fine. OK, now I don't really care about the width. I mean, it can stay nice and wide. That should be perfectly fine for what we're going to be doing. Let's go ahead and compile and save so that we don't lose that for any reason whatsoever. Now, with that Safety Collider selected, I'm going to right-click. Actually, we could do an overlap for that. So if you have the Safety Collider selected, you can say add event for Safety Collider, go under collision, and there's on component begin overlap. And that will work just fine. You have access to a whole bunch of other stuff. You could also, with nothing selected, just do a on actor begin overlap, which would basically do the same thing as far as we're concerned. But what we're going to do is get the other actor, which is whatever it is we just overlapped with, and we are going to cast that to my character. So essentially, we just want to make sure that whatever it is that collider just bumped into, it actually is the character. If it's not the character, we don't want to do anything. Now, depending on the game you're making, you may want to fudge this a little bit or change things around. If you, say for instance, you have physics objects rolling around and you don't want your lift to crush those, you may want to allow this to do overlaps for all dynamic objects. Here it's just an excuse for us to utilize casting, which is pretty much the only reason I'm doing it. So if this is true, if this tests out to true, then the object that we just bumped into is the character guaranteed. So at this point, we are going to run a branch. And this branch is going to be powered by whether or not the timeline is in the middle of playing. Now the reason we're putting this is kind of like a safety feature where if the lift is just sitting still, waiting to move again, and we bump into it, we don't want the lift to suddenly change direction. So we want to make sure first that the lift is playing before we do anything. Now to do that, you'll notice over here in the My Blueprint panel, we actually have access to the lift timeline as a variable. So we're going to drag that in and get it. So this is a reference to that timeline. And we can drag a wire off this and check and see if it is active. So that's basically the same as saying, is this timeline playing right now? And if true, then we need to continue seeing what's going on, like continue with the next test, which is to basically see what direction we're playing. Are we playing forward or are we playing back? Now there's a couple of different ways we can do that. We could query direction and make a variable out of that from over here. There's all kinds of ways. What we're going to do instead is drag another wire off lift timeline and check is playing. You also have access to is reversing, so you can do this in either direction. But we're going to say, we're going to check to see if this is playing, and we will run another branch. So if we are playing, that means the lift is essentially moving forward, in which case we want to reverse. If we are not playing, but we're active, that means that we are reversing, in which case we want to play. See how that works? So we're basically saying, are you playing right now? That means you're moving forward. OK, cool, then reverse. And if it's false, then we would have been reversing, so then we want to go in the other direction. Okay, so I think that should pretty much work. We should test it though. Let's compile, let's save, and let's see if anything explodes, because it's been known to happen every now and then. And we'll stand right under the lift. And oh, that didn't work at all. So that was less than ideal. Let's see why. So it looked like everything was successful. What I'm going to do real quick is we're going to just, well, I can't simulate. I have to play at the same time, and we have a very limited amount of screen space here. So let me select back here in the viewport and hit Alt-P. And we can't really make out the character, but I'll hit Shift F1 to get control back. We'll zoom out a little bit so we can see the entirety of the lift. It's doing its thing. Now, it goes up. Now, what I want to see is that first event actually fired during the overlap, and it looks like it worked just fine. Maybe I need to reverse my logic. Maybe I'm just running in the wrong direction here. Wouldn't be the first time. And boom. Okay. So let's see. It looks like it was on its way back down, so it was playing. Oh, it was reversing, and then it played. So that's kind of interesting. So what I'm going to do, and I've done this a few times on some of these videos, I'm going to do a quick pause, and I will diagnose what's happening. And when I come back, I'll just explain to you what I did to fix the problem. So I'll be right back. Okay, I'm back, and I have fixed the problem. And it's kind of an interesting one because, well, it shows that the logic is just not working the way I figured it should. And let me just point out kind of what I came across. So what we were doing is we were testing to see if we're playing. And if we're playing, we should reverse. And if we're reversing, we should play, which makes sense if you're trying to change the direction of something. But watch this. If I unplug both of these, and I just say if true, play, and if false, reverse, and we compile and save. And then if we test this, so lift goes up, stand under the lift, lift comes down, it just bounces off our head, which is exactly what we wanted to see. But here's where it gets interesting. As a test, I took is reversing, and if you just connected this up instead, you would expect this to break. You would expect it to go back to the behavior we had before, given the name. So let's stand under the lift this time, and boom, it goes up anyway. So it doesn't seem to care. It looks like right now, playing and reversing are giving us the same behavior. I think they're both actually testing for reversing under the hood. But for the moment, I'm not too worried about it. As long as this is working, then that's all good. It's just something I'd want to keep an eye on later in case something changed. Potentially got fixed, but I don't really want to use the word fix along with that. It is something that I'm definitely going to look into. Okay, so we've got our lift now acting intelligently. It is getting out of the way, or at least moving in the other direction if the player's standing under it, so we can no longer get squished and get those funny little collision problems, which is good. That's what we want. There's one more thing I want to do, and that is I want to be able to set how long it takes the lift to go from point A to point B, so from beginning to end. And we're going to do that by making a quick change to the play rate. So here's how we're going to set that up. Let's go ahead and make our graph nice and big. And right up here above our graph, kind of in this blank area, let's bring out another reference to the lift timeline. So we'll get that. And we're going to drag a wire off and say set play rate, like so. Then, when are we going to fire this? We're going to do this on begin play. So as soon as we start playing the game, we're going to set the play rate. And what do we want to set this to? Well, we've already got travel time in seconds as a public variable, and we should probably give that a default value. So let's say we set that to 2 seconds. Now, the math for this is pretty straightforward. If we do a divide float by float, or we could do, well, there's a bunch of ways to do it. Let's do 1 over our travel time in seconds. And we can plug that into the play rate, and that should be how long it takes to get there. And the other thing I'm going to do is if we are playing the game, as soon as we hit begin play, I want to take our test end location, and I want to set that to false. And the reason I'm doing that is if I was testing the end location and I play, I want to make sure that we start from the beginning and don't accidentally start from the end. So we'll compile, we'll save the character, because I don't know what changes made over there, but anyway. So cool, now we're standing, and you see the lift is moving a lot more slowly now. And we should test that out. So let's just select our lift, And let's speed it up. Let's say the travel time in seconds should be half a second, and we want the stop delay to be just 1 second. So we'll simulate. It's about half a second. It's sitting there for a second at either end, so that's good. Let's do another quick check. Let's say we wanted to take 5 seconds, and we want the delay to be 2 seconds. So now we simulate. And it feels like it's taking much longer. Yeah, that's great. I'm going to try to time it out. Let's see. 1, 2, 3, 4, 5. Yep, perfect. So yeah, there we go. So now we have a nicely customizable lift where we can control where it starts, where it's going. We can control how quickly it gets there, how long it waits once it arrives at its location. We can change its color if we want to. And we can even test that final location to make sure the level placement is nice and solid. So that is going to wrap up this video and wrap up this little introductory series over Paper 2D. I hope you enjoyed it, and I hope you tune in on our next series of videos over Unreal Engine 4. Take care.